Who ends up on academic probation, and can we predict it? When a student finishes their first year with a GPA below 2.0, they're placed on academic probation in many schools. But what led them there? Was it a lack of preparation, less engagement, demographic or living differences possibly? To answer that, we use logistic regression because now we're predicting a yes or no outcome. Our research question is, what factors increase or decrease the chances that a student ends up on academic probation after their first year? We've got a binary outcome, which is GPA below or above 2.0, but specifically here, GPA below 2.0, yes or no. A rich mix of predictors like standardized test scores, demographics, academic engagement, and living status. This makes a great case for logistic regression. And here's why we're going to use binary logistic regression. Our dependent variable is binary. Was the student placed on academic probation? Yes or no? Our predictors are a mix of continuous, like ACT scores, age, and categorical, like gender, utilizing tutoring status, or living status. We want to estimate the odds of probation given a set of predictors. And linear regression isn't appropriate here because the outcome isn't continuous. Instead, we're modeling probabilities and not means. Logistic regression gives us four pieces: an odds ratio, or exponent B, how much a unit change in one variable increases or decreases the odds of being on probation, as well as significant tests, which are p-values for each predictor to assess importance. Then we have predicted probabilities. What's the chance a student ends up on probation? And finally, we have model fit metrics. To run a logistic regression in SPSS, we're going to go to Analyze, then Regression, and click Binary Logistic as your final step. Set academic probation as the dependent variable. Select all relevant predictors. For organization purposes, we'll do academic preparedness, which is first all of our ACT scores, all four of them: math, science, English, and reading. We'll also classify undecided major status into preparedness. Then in demographics, we have gender, which is a binary variable for male for the ease of use specific here, a continuous variable age, and in-state residency and legacy status, both of which are binary. Now to living status, we have on-campus variable, and we will add whether a student has a job on campus as well. And finally, to academic activity, we will add the use of tutoring services, attending supplemental instruction, and membership in a fraternity or sorority. SPS gives you coefficient beta and exponent beta for odds ratios, as well as significance levels and overall model accuracy and goodness of fit. Let's walk through the model itself first, then walk backwards to the model performance. Let's interpret what we can take away from our statistical significant variables. Overall, we take away that students with higher math as well as science scores had higher GPAs. For every 1 point increase in math yields a decrease in the odds of probation, about the same as the impact for science. And undecided majors have about 1.6 times more likely chance of being put on probation, all other things held constant. Males have a markedly higher odds than females of ending up on probation. This is significant and something worth noting, probably the most significant factor in this model as we observe. Those in state are actually higher in terms of their odds of being probation as well. And the only remaining statistically significant variable is using supplemental instruction. So now let's break down the results in pure interpretation. So being male and from in-state both significantly increase the odds of academic probation. Students who attend SI were dramatically less likely to end up on probation. Higher ACT math and science scores both help improve or reduce the risk. So in other words, support helps, math and science matters, and demographic patterns may flag risk. Now to the model performance. The model is statistically significant overall and explains about 12.4% of the variance in probation status. That might not sound like much, but in real world student success models, anything in the 10 to 20% range is fairly solid. Now that we've run the logistic regression, let's look at how well the model actually performed, but in a different means than the pseudo R-square, since the R-square value does not work the same way in a logistic regression as it does in plotting a linear model. What we have here is what's called a confusion matrix, also called a classification matrix, which is a snapshot of the model's predictions versus reality. Here's what we see. Overall, the model had 86% accuracy rate, but what we learned is the model is great at predicting who will not be on probation at about 99%, but not great at predicting who will be on probation, and let me walk you through it. It correctly identified 1,225 students who were not on probation, and also flagged 21 students who were on probation. But unfortunately, it missed 189 students who actually ended up on probation, and it had 18 false alarms, flagging students who actually weren't at risk. On the surface, the model looks pretty accurate, 86% overall. But here's the catch. Most students weren't on probation to begin with. When it comes to actually catching students at risk, the model struggled. It only caught about 10% of actual probation cases. That's a very high false negative rate. This is a classic case of class imbalance. When the group we care about most is small, the model tends to ignore it, unfortunately. So what can we do? We want to catch more students at risk. We could lower the threshold for flagging a student, like transitioning from 0.5 to something more sensitive, like 0.1 or 0.2. We could also use an oversampling technique, like SMOTE or synthetic minority oversampling technique. We can also apply cost-sensitive classification, where missing an at-risk student carries a higher penalty. Or we could bring in more data, like class absences or high school GPA, to improve prediction. But this is all another conversation for another time. And that's logistic regression. Our go-to when the outcome is binary, and the question is, what increases or decreasing the likelihood of something happening? This specific example wraps up the core statistical modeling journey. But in future videos, we're going to go a great deal further, visualizing predictions, comparing models, getting deeper into the depths and the rigor of models, but also more applied concepts in marketing, finance, and other areas. We want to build interpretable models for decision making. If you like this video, hit that subscribe button and stay tuned, and always stay curious.